Hello students, myself Ashish Chawla, and today we discuss the problem based on basic proportionality theorem and its converse. Now the first question is that there is a figure, there is a triangle ABC, and there is a point M on the line AC, and when we draw a line through M, it will intersect the line AB at N and produce so on, and we also producing the side BC. Now these two lines intersect at the point called as T. Now the line, and there is a point X on the side BC such that the line XN is parallel to AC. It is given that the line XN is parallel to AC and the line XM is parallel to AB. Line XM is parallel to AB. It is given in this question. And what we have to show this, we have to show that, or we have to prove that Tx square is equals to Tb into Tc. We have to show that Tx square is equals to Tb into Tc. Now, to solve this problem, because we have to show that Tx square should be equals to Tb into Tc. Now, wherever we see the lines are parallel, we can apply the basic proportionality theorem. So, in this question, it is given that Xn is parallel to AC. The line Xn is parallel to AC, or we can say that the Xn is parallel to MC because MC is a part of AC. So, Xn is parallel to AC. It means Xn is parallel to MC. Xn is parallel to MC. Now, in triangle TMC, Xn is parallel to MC. As Xn is parallel to MC, we can apply the basic proportionality theorem. Xn is parallel to MC, we can apply the basic proportionality theorem. That is Tx upon Tc is equals to Tn upon Tn. Now, in the same way, again in this question we have given that the line XM is parallel to AB. The line XM is parallel to AB, or we can say that XM is parallel to NB because NB is a part of AB. XM is parallel to AB, but NB is a part of AB, so we can say that XM is parallel to NB also. Now, in triangle TMX, we apply the basic proportionality theorem. By BPT we can say that TB upon TX is equals to Tn upon Tn. TB upon Tx is equals to Tn upon Tn. Now this is our first equation, let's see, and this is second equation. Now comparing these two equations, we can say that their right hand sides are same by comparing equation number 1 and equation number 2. We can say that their right hand sides are same, so the left hand side are also same. That means Tx upon Tc should be equals to Tb upon Tx. Now by cross multiplying, we can say that Tx square is equals to Tb into Tc. Tx square is equals to Tb into Tc. So this we want to prove. Now the next question is In the next question, there is a triangle ABC. Let's say there is a triangle, let's say PQR. There is a triangle PQR, and there is a line. Now there is a line. Let this point is A and connect it to Q and R and EF, and there is a point D. D is connected and DF is connected. Now in this question, it is given that the line DE is parallel to AQ. It is in the question, this figure is given to you, and it is given that DE is parallel to AQ and DF is parallel to AR. DF is parallel to AR. It is given. That is, DE is parallel to AQ and DF is parallel to AR. And we have to prove this. We have to prove that is EF, the line EF is parallel to QR. So this is our question. In this question, it is given that D is parallel to AQ and DF is parallel to AR. Now wherever we see the lines are parallel, we can apply the basic proportionality theorem. So the first situation is given that D is parallel to AQ. DE is parallel to AQ. So for this we consider a triangle PAQ. In triangle PAQ, it is given that DE is parallel to AQ. Now we can apply the BPT. So by BPT, we can say that PE upon EQ is equals to PD upon DA by basic proportionality theorem. Now in the same way, it is also given to you that DF is parallel to AR. The line DF is parallel to AR. For this we consider a triangle PAR. Now in triangle PAR, DF is parallel to AR. DF is parallel to AR. Now we can apply the basic proportion theorem here again. By BPT, we can say that PD upon DA is equals to PF upon FR. Let's say this equation is 1. Now this equation 2. Now from these two equations, by comparing these two equations, here PD by DA, here again PD by DA. So these are common. So we can say that PE upon EQ should be equals to PF upon FR. Now by comparing 1 and 2, we can say that by comparing 1 and 2, we can say that PE upon EQ is equals to PF upon FR. Now as the ratio of these two sides are equal, PE upon EQ is equals to PF upon FR. So it means the line EF, it means line EF is dividing, PQ and PR in the same ratio. So we can say that by converse of BT, so by converse of basic proportionality theorem, we can say that EF is parallel to QR because it divides the two sides of a triangle in the same ratio. So by converse of BPT, we can say that EF is parallel to QR. We can do one more problem, that is, we have to show that the diagonals of a trapezium divides each other in the same ratio. Diagonal of trapezium intersect each other in the same ratio. That we want to prove. That is, the diagonal of a trapezium intersect each other in the same ratio. It means there is a trapezium Let's say there is a trapezium ABCD and there is a diagonal AC and there is a diagonal BD. Let's say they are intersect at the point 2. And what we have to prove? We have to prove that OD upon OB is equals to OC upon OA. That we have to prove. Now, what we have given here, we have given ABCD is a trapezium in which AB is parallel to CD. Now to prove this, we have to do one construction. From this point O, I have to draw a line which is parallel to AB. Let's say this line is cut the AD at G. Now draw OG parallel to AB. As AB and CD are parallel, so OG is parallel to AB as well as CD. Okay. Now we consider triangle DAB. In triangle DAB, OG is parallel to AB. Now by VPT, we can say that DG upon GA is equals to OD upon OB by VPT. We can say that DG upon GA is equals to OD upon OB. Now, in the same way, we consider the triangle DAC. Now, in triangle DAC, OG is parallel to CD. OG is parallel to CD. Now, again, we apply the basic proportionality theorem here again. So, by VPT, we can say that AG, or you can say GA upon DG, GA upon DG is equals to OA upon OC. Now we do the reciprocal of this. We get DG upon GA is equals to OC upon OA. Now let's say this is equation number 1 and this is equation number 2. Now by comparing 1 and 2, we see that their right hand side are same, that is DG by GA. So their left hand side is also same. So by comparing 1 and 2, we can say that OD upon OB is equals to OC upon OA. Thank you.